For most of us, childhood astronomy began with a list that felt like gospel. Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and, at the very edge, Pluto. 9 planets circling a single star. It was neat, tidy, and easy to memorize. Then suddenly, in 2006, Pluto was expelled from the planetary club, stripped of its crown, and demoted to the ambiguous rank of dwarf planet. It was as if someone had quietly rewritten the ending of a story we thought we knew by heart. And people didn't like it. Because Pluto wasn't just a distant ball of ice. It had become a cultural companion, a symbol of the little guy in a cosmic lineup of giants. Could scientists really tell us to simply forget about it? But the truth is, the Pluto saga has never been about sentimentality alone. It's about discovery, disappointment, and ultimately, redemption. For even as Pluto's planetary title was being revoked, another story was unfolding. One that would prove Pluto is stranger, more complex, and more alive than anyone had dared to imagine. That story began in the same year as the demotion, when NASA launched a fragile, lightweight probe named New Horizons. Its destination was the frozen wilderness at the edge of the solar system. Its mission? To reveal what Pluto really was. To understand why Pluto's fate became so controversial, we need to step backward in time to the 19th century. This was the golden age of skywatchers, when telescopes were improving and astronomy was maturing into a serious science. In those days, the solar system seemed crowded. Each time a faint new dot was spotted against the background stars, whether it was a moon, a large asteroid, or something more mysterious, there was a tendency to declare a new planet had been found. For a brief period, the solar system boasted nearly 20 of them. Of course, this was unsustainable. The very word planet was losing meaning. To restore order, astronomers began writing stricter definitions. A planet, they said, must circle the sun directly, not another world. It must also stand out as unique in its neighborhood, not one of many pebbles in a belt of rubble. Fast forward to 1930, when a young amateur astronomer named Clyde Tombaugh, armed with patience and meticulous skill, discovered a dim, wandering point of light beyond Neptune. He had been tasked with searching for a hypothetical planet X that was believed to tug on the orbits of Uranus and Neptune. After months of painstaking observation, the faint smudge he captured turned out to be real, a body larger than most asteroids orbiting far from the sun. Excitement rippled through the scientific world. Tombaugh had found Pluto, and for the next 75 years, generations of school children grew up knowing it as the 9th planet. But astronomy, unlike myth, is never static. Telescopes grew sharper, detectors more sensitive, and computers more powerful. By the turn of the 21st century, astronomers began to realize Pluto wasn't unique after all. It was merely the brightest piece of a sprawling collection of icy debris called the Kuiper Belt, a kind of celestial scrapyard filled with leftover material from the birth of the solar system. Even worse for Pluto, some of its neighbors turned out to be just as big. One of them, Eris, even rivaled Pluto in size. And so in 2006, the International Astronomical Union drew a new line in the sand. For an object to be a planet, it must not only orbit the sun and be large enough for gravity to shape it into a sphere, but it must also have the gravitational dominance to, quote, clear its neighborhood, sweeping up debris and ruling its orbital zone like a monarch. Pluto failed the final test. Its orbit cuts through the Kuiper Belt, tangled with countless other icy bodies. By this definition, Pluto was not a planet, but a dwarf planet, relegated to the company of the very objects that had revealed its inadequacy. It felt like an indignity. And yet, even as the public mourned, engineers at Johns Hopkins University were preparing something extraordinary. That very same year, a probe was launched toward Pluto, a journey of unprecedented ambition. New Horizons was barely the size of a baby grand piano, weighing just about 1,000 pounds, but it carried with it humanity's hopes of a first-ever close look at Pluto. To cover the vast gulf of space, billions of kilometers, in any reasonable time, it needed a dramatic send-off. Strapped to an Atlas V rocket with 5 extra boosters, the little probe was hurled into space with such ferocity that it passed the moon in just 9 hours, faster than any spacecraft in history. Within a year, it had already crossed paths with Jupiter, using the giant planet's immense gravity as a slingshot to gain even more speed. But even with that boost, Pluto remained stubbornly distant. It would take almost a decade for New Horizons to cross the outer solar system. For years, it sailed silently through the darkness, sleeping, waking, and sending back occasional signals of its health. Then, in the summer of 2015, the faint dots of Pluto and its moon Charon grew into worlds. The long wait was over. Humanity's first encounter with Pluto was about to begin. The first images stunned everyone. From Earth, Pluto had always been nothing more than a blurred speck. Now, suddenly, we saw a world painted in unexpected colors: deep crimson, pale gold, icy blue, and brilliant white. Dominating one hemisphere was a vast, pale, heart-shaped feature, an enormous plain of frozen nitrogen that seemed almost too perfect, too symbolic to be natural. One side. Closer inspection revealed rivers of ice flowing like glaciers, but not the water ice we know on Earth. At Pluto's temperatures, around -229 degrees Celsius, water ice is as hard as granite. Instead, these glaciers are composed of nitrogen ice, soft and mobile under Pluto's conditions, creeping across the landscape and erasing old scars. The plain, later named Sputnik Planitia, is roughly the size of Texas. The polygonal patterns etched across it suggested convection cells, evidence of heat slowly bubbling upward from Pluto's core, stirring the frozen surface. Above this icy expanse, Pluto wears a delicate, shimmering veil. Its thin atmosphere, composed mostly of nitrogen with traces of methane, stretches far into space, forming hazy layers that scatter sunlight into shades of blue. It is fragile, with a surface pressure 1,000,000 times weaker than Earth's, yet dynamic. As Pluto swings along its eccentric orbit, sometimes closer to the Sun, sometimes farther, this atmosphere thickens and thins, waxing and waning in cosmic rhythm. At times, it may even grow dense enough for liquid nitrogen to briefly pool on the surface, a fleeting hint of oceans on a world far too cold for liquid water. But Pluto's surprises did not end with glaciers and haze. To the west of the Great Heart sprawls a vast, dark stain, a blood-red swath unofficially nicknamed Cthulhu Macula. Its color comes from complex organic molecules called pholins, formed when ultraviolet radiation from the sun bombards methane and carbon dioxide in the atmosphere. These molecules, sticky and reddish, drift downward like alien snow, blanketing the terrain. Such chemistry hints at the precursors of life, raising tantalizing questions about what organic processes might be possible even in such frigid conditions. And then there are Pluto's mountains, rising taller than the Rockies, carved not from stone, but from water ice so strong it behaves like rock. Among them towers Right Mons, a massive dome over 150 kilometers wide and 5 kilometers tall, believed to be an ice volcano. Instead of molten lava, it erupts with slurries of water, ammonia, and methane, cryovolcanoes unlike anything on Earth. What startled scientists most was how fresh these features appeared. Impact craters were sparse, implying that these volcanoes may have erupted in the relatively recent past, geologically speaking. Somehow, despite its small size and distant orbit, Pluto retains internal heat to drive such activity. Where does this heat come from? On the icy moons of Jupiter and Saturn, tidal forces from giant planets knead their interiors, keeping them warm. But Pluto floats in solitude. Some theories suggest radioactive elements deep in its rocky core release enough energy to maintain a subterranean ocean beneath the crust. Others propose that the violent impact that created its moon Charon injected long-lasting heat. Whatever the explanation, Pluto defies expectations. It is not frozen solid, not entirely silent, but active, dynamic, and possibly home to a liquid ocean hidden below its icy skin. And then there is Charon itself. Nearly half Pluto's size, it forms a unique double system, the two worlds locked in a mutual orbit around a common center of gravity that lies outside Pluto itself. This strange dance means that Pluto and Charon are eternally face-to-face, each showing the same hemisphere to the other. From one side of Pluto, Charon forever hangs in the same spot in the sky. From the far side, it is never visible at all. Their relationship hints at a violent past. Perhaps, long ago, a colossal collision between Pluto and another large Kuiper Belt object produced this pair. Instead of shattering them, the impact fused their destinies. The scars of that encounter may still be visible today in Pluto's vast, heart-shaped basin, lying almost directly opposite Charon's orbital position. And in turn, Pluto's cryovolcanic eruptions may be sprinkling organic material into space, some of which settles onto Charon's pole, staining it a reddish hue. By the time New Horizons passed by, the encounter lasted mere days, a fleeting glance at a world billions of years in the making. Yet in that brief time, it shattered every preconception we had. Pluto may no longer be a planet, but it is something perhaps more fascinating, a complex living world at the frontier of the solar system, defying categories and demanding we rethink what it means to be a world. When New Horizons sailed past Pluto, the world held its breath. The transmission of data took hours to crawl back across billions of kilometers, each packet of information traveling at the speed of light, yet still requiring patience. Slowly, piece by piece, the images assembled, and humanity finally looked Pluto in the face. For a brief moment, a distant speck became a place, tangible, textured, and heartbreakingly beautiful. And then, just as quickly, it slipped away again, shrinking into the rear view of human exploration. But the story of Pluto does not end with that flyby. What New Horizons revealed was only the surface of a mystery. Beneath Pluto's icy crust, a hidden ocean may slosh in darkness, warmed by radioactive decay and insulated by layers of nitrogen and methane ice. If such an ocean exists, it raises questions that ripple far beyond Pluto. Could conditions in that hidden sea resemble the environments where life began on Earth? Could simple microbes, or precursors of life, endure in those frigid depths? We may never know for certain, but the possibility transforms Pluto from a forgotten dwarf planet into a potential outpost of astrobiological intrigue. And then there is the Kuiper Belt itself, that immense halo of frozen debris encircling the solar system beyond Neptune. For centuries, it was invisible to us, a blank canvas of darkness. Now, with Pluto as its emissary, we understand that this region is not empty, but filled with worlds. Some are smaller, irregular, and rocky. Others are larger, icy, and mysterious. Eris, Haumea, and Makemake. Each rivals Pluto in significance, each telling a piece of the solar system's unfinished story. Together, they reveal that the outskirts of our star system are not a barren wasteland, but a second frontier, teeming with strange landscapes. Pluto was simply the first to step into the light. What fascinates scientists most is how vibrant and varied Pluto turned out to be. Before 2015, most textbooks described it as a dull ball of frozen rock, static and unchanging. Yet New Horizons showed us glaciers flowing like rivers, mountains taller than the Alps, and plains reshaped by convection. The dwarf planet that had been dismissed as insignificant was suddenly recast as a laboratory of exotic physics, where nitrogen replaces water, where sunlight sculpted tholins fall like crimson snow, and where cryovolcanoes breathe methane into an alien sky. Even its atmosphere refused to conform to expectations. Instead of being a thin, featureless haze, it displayed intricate, layered fog bands stretching hundreds of kilometers above the surface. These layers scatter sunlight into delicate blues and purples, a fragile halo around a distant world. It was a reminder that atmospheres, no matter how thin, are complex ecosystems of chemistry and physics, and Pluto's may evolve dramatically as it journeys along its elongated orbit, swelling and collapsing in cycles that last centuries. Yet, for all that wonder, Pluto remains an exile in astronomical taxonomy. It is not a planet in the official sense, not the ninth bead on the string of the solar system, but a dwarf. And maybe that's fitting. Pluto refuses to be boxed into categories. It is neither fully planet nor asteroid, neither silent nor alive, neither near nor impossibly far. It sits in between, a liminal world, one that breaks rules and insists that our definitions are too simple. This is why, in some ways, Pluto's demotion was its salvation. Had it remained a planet in the classical sense, perhaps we would have overlooked its complexity. Instead, the debate drew attention, controversy, and curiosity. Assumptions, and how wonder thrives at the edges of knowledge. And the probe that delivered this revelation, New Horizons, did not stop there. After its swift encounter with Pluto, it pressed onward into the Kuiper Belt, venturing into unexplored territory. In 2019, it flew past a contact binary object now called Arrokoth, a snowman-shaped remnant from the earliest days of the solar system. Unlike Pluto, Arrokoth has remained largely unchanged for billions of years, a fossil from creation. The contrast was striking. Pluto, dynamic and surprisingly active, and Arrokoth, frozen in time, together illustrated the range of fates awaiting the debris of planet building. As of today, New Horizons continues its journey, drifting farther into interstellar space, its instruments still listening, still transmitting, though the signals grow ever fainter. Eventually, it will fall silent. Another tiny artifact among the stars, carrying with it the memory of the time humanity dared to chase Pluto. And so, we return to the question that began this journey. What is Pluto, really? Is it a planet, a dwarf, or something else entirely? Perhaps the answer is less important than the perspective Pluto gives us. At the edge of the solar system, it reminds us that our categories are human inventions, while the universe follows its own logic. Pluto is a world, and in being a world, it defies dismissal. Its mountains, valleys, glaciers, atmosphere, and possible ocean tell us that even the smallest bodies can harbor grandeur. There is also something poetic in Pluto's exile. Once counted among the planets, then cast out, it has become more fascinating than ever. Its story reflects the nature of science itself, always provisional, always questioning, always ready to overturn its own truths in pursuit of deeper understanding. We thought we had 9 planets. We thought Pluto was a frozen rock. We thought it was insignificant. And each time, reality proved us wrong. For the generations who grew up with Pluto as the 9th planet, there is a kind of bittersweet justice here. You may no longer be able to find Pluto listed beside Neptune in a schoolbook diagram, but what you can find is something better. A world with a beating heart of ice. If you've enjoyed this journey into Pluto's hidden world, and the story of how a so-called dwarf planet became one of the most fascinating destinations in our solar system, don't forget to like, share, and subscribe, because the cosmos is full of surprises, and together we can keep exploring them, one mystery at a time.